Imagine a world where no medical decision is made about a patient without fully understanding their individual immune systems. That's what IMU Biosciences is trying to do, and I'm here today to talk to their two founders about their amazing, innovative company and about next generation precision medicine, which is the future. And actually the future is here now. Adam and Tom, thank you so much for meeting with me today. I'm so excited about hearing about IMU Biosciences. Can you tell me how the story began?
I've spent my career developing approaches to be able to understand and analyse the immune system in all of its complexity. What we've built here is an approach to be able to measure the immune system in really an unparalleled level of detail, but also at enormous scale. And we can use the technology, the data and AI to do something really remarkable, which is understand an individual person's immune system, and that's really important for all sorts of different applications. It's fundamental to stopping us developing cancer, for example. It's involved in neurodegeneration, metabolism, healthy aging, and many, many other things.
And as you mentioned earlier, you're not just looking at the immune system, but you're also adding in machine learning and AI to get the best possible outcomes with the information that you're feeding in. Is there a gap there? Are you the only people doing this? Why have you decided to do this?
There is an enormous gap to being able to understand a person or a patient's immune system. We have a really good understanding of how the immune system works in a textbook, but we don't know how it works in you or I. That gap is simply a lack of data with appropriate level of complexity. These instruments you see behind you, we can use these to measure 80 million data points from a blood sample that collectively describe a person's immune system. That's a huge amount of data, but we can do it on hundreds and hundreds and hundreds of samples every week. And we're using that data to build this understanding, and the only way that you can extract the maximum value from all of this is to use machine learning and AI, and that's exactly what we're doing.
In my role, I'm always trying to show people that purpose can drive creativity and innovation. I feel like what you guys do is the bedrock of like really thinking about doing something purposeful and using creativity and innovation together. How do you think you connect the two?
This is cutting edge science, and it requires innovation, collaboration, and that's something that I think we've done fantastically well here. One of the key principles here is that good science requires collaboration, and that's something we've been very successful at.
When we were chatting earlier, you were talking about next-gen precision medicine. Could you please explain what it is and why it's important?
When it comes to drugs that target the immune system, it's definitely not the case that one size fits all. And there is a real need to personalize how you pair drugs with patients. And what we're doing here is we're using information on those patients' immune systems to identify the right drug that's going to work for them.
It sounds so futuristic, but it's so brilliant to have people talking more and more about the importance of individualized medicine. It'd be so amazing for the individual, for government bank balances, you know, if drugs and medicine was much more targeted. What are sort of three tangible examples of what this could mean for patients?
The last couple of decades, one of the biggest revolutions in how we think about new treatments is in cancer immunotherapy. The idea that we could actually target the immune system to help in the fight against a tumor. Only around 20% of people, for the most part, respond to these drugs in any meaningful way. When we prescribe these drugs at the moment, we don't have a good enough understanding of the immune system of the patients. And only by having that really good understanding of the immune system are we going to understand, will a person respond to this treatment, or is there another treatment that's better for this person?
One area where this approach can provide real value is in solid organ transplantation. Once you've transplanted that organ, over a period of time, the patient's own immune system will recognize it as foreign. And ultimately what this leads to is that the immune system attacks the organ, and this is a process we call transplant rejection. And we can see that process happening long before the symptoms develop in these patients. That you can intervene much more effectively, and you can preserve the function of that organ and ultimately lengthen the lifespan and the quality of life for the patient. Another application is essentially that problem on its head. So we've all heard about stem cell transplantation. So you are transplanting the immune system in the form of stem cells from a healthy donor into a patient who's had their immune system wiped out, and the goal is that it repopulates and the patient then has a healthy immune system that can fight the cancer and fight off infection, etc. We have the opposite problem now, where that immune system can recognise the patient as foreign and mount a response that's called graft versus host disease that can be lethal. There's a real need to understand what that immune system looks like and to understand what are the key components that will, first of all, repopulate the patient, but also not lead to the development of this awful graft versus host condition. If you can keep those patients healthier for longer, they're not in hospital with infections, that you're not having to manage the rejection for as long.
Exactly. I think you might have someone that wants to come and do some work in here. Please do come by, as long as you don't mind us chatting while you're working. What's your guys' long-term mission for IMU, and how are you going to get there?
The mission is that we can bring this understanding of the immune system to patients that need it. A central aspect of what we do is that we need to generate the data on these patients to understand what's going on, and we can't do that in isolation. So we've teamed up with a fantastic group of people to help us do that.
I mean, we truly believe that there's a future where no medical decision is made without a deep understanding of a patient's immune system, and that's precisely the type of thing we're trying to achieve at IMU Biosciences.
Oh, it's been so nice to talk to you both. Thank you very much for taking the time, and you have got the cleanest lab I've ever seen, and you're the most articulate scientist I've ever met, so it's been lovely to chat to you both. Thank you very much.
Thank you.